Hello guys, so we are back again and we will continue with our GP thing. Okay, we have learned the term formula of GP. Okay, general term formula, sum of n terms in GP and sum of infinite terms in GP. I have derived all the formulas and we will just revise. Okay, take a quick revision to all these formulas. Okay, Tn was what? A r ki power n minus 1. Sn was what? A r ki power n minus 1 upon r minus 1. It can also be converted as a into 1 minus r ki power n upon 1 minus r. Okay, depending upon the situation. Now finally the Sn formula, okay, which is what? Infinite. Okay, sum of infinite terms of a GP is nothing but a upon what? 1 minus r. The condition was mod r less than 1, which is nothing but mod r less than minus 1 to 1. Okay, all these things we had done. Okay, so we are going to continue, okay, with our further questions. Okay, we will do some questions and then move on to geometric mean. Okay, the first question which we are going to do is this question. Okay, these questions. Okay, the question says, this question is very common and you can see it every textbook. Okay, in every textbook. Okay, it is a board question. Okay, and these are bases, means this can be used as a base of some big questions. Okay, so take a quick, means keep it mind this question. Okay, now listen, if you observe this question which says s is equals to 5 plus double 55 plus 555 5555 till n terms. Okay, now here it is not a GP. Okay, similarly it is not a AP. Okay, now how we will make it a GP, that is the process you have to learn. Okay, so this question is just all about learning. Okay, so what is the first step? Take, no matter what number it is, take 5 common in that. What you get? 1 plus double 1 plus triple 1. Okay, 4 times 1 until what? N term. Okay, now the second step which you have to learn is divide it and multiply by 9. Okay, 9, 99, 999, then 9, 9, 9, 9 till dot n terms. Okay, now just keep this in mind that, and here it will be 9 ki power some n. Okay, 9 ki power n. Okay, like that. Okay, now what was the purpose of multiplying it with 9? How it can be useful? It is useful like this. I can write 9 as 10 minus 1, 100 minus 1. Okay, 1000. Okay, this is 999. Okay, this 1000 minus 1 and like that. Okay, till 10 ki power n minus 1. Okay, now if you observe clearly, if I write this as like this, it is 10 plus 100 plus 1000 till what? Plus 10 ki power n. And if I separate this here, 1 1 1 1 till what? N terms. Okay, then what I get? I get 5 by 9 ki power. Okay, like here I want to get the sum of this. It is nothing but a, the ratio is 10. Okay, 10 ki power 10 minus 1 upon, okay, 10 power n minus 1 upon 10 minus 1. Okay, this is the basic. Okay, we have applied. Okay, you can break it like that. Okay, for your understanding. Okay, this is a sum of n terms, okay, of a GP, and this is just simple, and 1 is added n times, so I find out its means its sum using a into r ki power n minus 1 upon r minus 1. Okay, and here it all summation will give me n. Okay, so I got this thing. Now the answer is like this: 5 by 9 into 10 power n minus 1 upon 9 minus n. Okay, so this is our answer, and this question is just you have to keep in mind because this question will be repeated many times. Okay, you will see something, instead of here 5 it will be 4, instead of here 4, like that, 8 9 7. Okay, if it is 9 you can directly take it common, there is no need of okay, then this step will not come. Okay, that is the means trick part. Okay, and if it is 10 then there is no problem, only it is GP only. Okay, now if it is 11 like that, then you have to break it in 10 and like that. Okay, now further on, let an be the, then second question, let an be the nth term of a GP. Okay, of positive terms, let Okay, let summation n is equals to 1 to 100 a to n is equals to alpha, and summation n is equals to 1 to 100 a to n minus 1 is equals to beta, such that alpha is not equal to beta. Then the ratio, common ratio is, okay, we want to find the common ratio. They have given us the summation value. Okay, now this question, similar question we have done in AP. Okay, what will be the difference? Okay, the difference will be very clear. Okay, you will come to know the difference. Okay, the thing will be like this. Okay, the summation, if I open it, n is equals to 1 to 100, okay, a to n, okay, will be what? Will be, so summation an is equals to 1 to 100. If we analyze this one, okay, if we analyze this a to n, it will be what? A, if we place 1 2 a4 a6 a8 till what? A200. At a100, at n is equals to 100, it will give a200. Okay, now it is in GP, and in GP how we consider terms? We consider it like a2 will be what? AR, a4 will be what? A cube, a6 will be what? A5, a8 will be a7, then a200 will be AR199. Similarly, okay, and it is what equal to? It is equal to alpha. Similarly, we will analyze this one, second one, which is n is equals to 1 to 100, and this is beta. Okay, this is a 2 minus 1. Okay, and its value is equal to beta from here. Okay, now if I open it, what I get? A1, a3, a5, a7 till what? A199. Okay, I get till A199. Now let me take the next page and we will analyze it further. Okay, this is okay, this is the basic formula which we have discussed in the starting lecture. Okay, now here we got A19. Now we will open it, means how we consider terms in AP. We will just put it like that: AR square, AR raised to 4, AR raised to 6, until what? AR raised to 198. Okay, so what we have? It is equal to beta. Okay, now the one thing, this thing, okay, this first thing, if I take r common from here, this can become like that. Okay, so I will take r common from alpha. So if I take r common in alpha, what I have? AR square, AR raised to 4, AR raised to 6, and further on what we have here? A198, right? And this is what? Our alpha. Now if I divide alpha by beta, what I have? R. This thing is similar to this thing. Okay, if I take this, okay, this thing, okay, this thing is similar to this. So beta, this term whole will cancel out with this, which will give me r. And what they have told us to find out the common ratio, which is nothing but alpha by beta. Okay, so this question was just the application of summation which we have studied. Like the difference was, instead of in AP we used to consider term like a plus d, a plus 2d, but here in GP we consider ar square. Okay, so be conscious with the terms. Okay, if you be conscious with the terms, these questions will be very easy for you. Okay, now let's take the next question. Okay, the next question is as follow. The question says the sum of infinite terms of a GP is 15. Okay, and the sum of the squares is 45. Okay, now let's understand the problem. They're telling find the series. In any question, if they tell you to find the series, it doesn't mean you have to find a and r. Okay, you have to just find a and r. Okay, that's all. Okay, they're not telling anything much. Okay, now we will just study what we want. Okay, so if I consider this as series, because in GP we consider the series. Okay, AR some, okay, I'm considering series. Okay, not sequence. Okay, AR square, AR cube, okay, like that till infinite, because it is telling sum of infinite terms. Okay, so its sum will be what? It will be a upon 1 minus r, right, which is nothing but equal to 15. Further on, if I observe, if I square it, what I get? This sequence will be like that: a square r square, a square r raised to 4, a square r raised to 6 till infinite. Now here this sequence infinity, its term will be a square 1 minus r square will be what? Equal to 45, what they have told. Now here I have it as A, this I have it as B. Now I want to find R and A. Okay, when such things appear, just try to convert this by squaring. Okay, that is the best approach. Okay, the other approaches are not good. Okay, so just try to do this thing. Okay, okay, so if I square this, I get A square upon 1 minus R the whole square is equals to 15 square, 225. Okay, so here if I divide this term by this, okay, 225 by 45. Okay, and this will be what? A square will cancel out, which will give me 1 minus R the whole square upon 1 minus R square. Okay, 45, this will be 9, this will be 4, 5, this will be 1, that will be 5. Okay, so 5 should be equal to 1 minus R into 1 plus R upon 1 minus R into 1 minus R, right? This will cancel out, which will give me 5 is equals to 1 minus R is equals to 1 plus R. Further on, if I calculate it, it is nothing but 5 minus 5 R should be 1 plus R, which gives me 6R should be equal to 6R should be equal to, okay, should be equal to 4, which gives me R is equals to 2 by 3. So I got my R. Okay, now if I got my R, can I find my A? If I put this value here, what I get? A upon, this will be nothing but 3, this will become 1, and this will be 15. So I got A is equals to 5. Okay, so my A is 5 and R is 2 by 3. So we are done with this question. The basic thing was just analyzing the series, okay, and getting the sum, applying the formula, and that's all. Okay, now the next question is, if the roots of the cubic ax cube plus bx square plus cx plus d equal to 0 are in GP, then prove that c cube a is equals to b cube d. Okay, we want to prove this. Okay, now if you have stated quadratic equation cubic, that the degree of the equation decide the number of roots which it will have. Okay, so I know it will have roots like it will have roots some alpha, beta, gamma. Okay, like this. Okay, now I know alpha into means product of the root will be what? Minus d by a. Sum of the root alpha plus beta plus gamma will be minus b by a, and the last thing alpha beta plus beta gamma plus gamma alpha will be nothing but c by a. Okay, we know that much. But in GP, how we consider, if three terms are in GP, how we consider them? Okay, a, why we are considering a by r, a and ar? Because whenever you see in question that product is happening of terms, okay, odd number, then try to take these terms in GP, because they will cancel out and give you directly a value. Okay, so here you can see, if I take product, a cube will be nothing but minus d by a. One thing here, if I take a common, I get 1 by r plus 1 plus r will be nothing but minus b by a. Here it will be a square 1 by r plus 1 will be equal to c by a. So we got all the things. Okay, now what we should do? Okay, now here if I substitute the value of this, okay, if I substitute the value of this here, what I get? Okay, r square. Okay, if I square it and substitute the value here, then we see, let's what we get. If I square this, what I have? A square into 1 minus r plus 1 plus r. Okay, okay, we have this thing. Okay, the whole square is b square by a. Okay, okay, let's think how we can substitute this. Okay, we have a into a b by a. If I substitute this value here, a into r. Okay, so let's substitute this value. A into, there will be 1 a into 1 by r plus 1. Okay, and 1 a will be there. So if I substitute this value, it will be minus b by a is equals to c by a. Okay, Okay, so a will cancel out, which gives me a is nothing but minus c by b. Okay, so we got a value. Okay, now if I put the a value here in this equation, what we have, c cube minus b cube should be equal to d minus d upon a. So what we have finally, minus minus will cancel out, I am doing it here. Okay, it is c cube into a into b cube into d. So we got our answer. But the main part, means the main part was just analyzing how we will do it. Okay, how we will do it. Okay, if you know how we will do it, means the calculation part, means here substitution like that. Okay, that takes a time, but if you means are good with calculation, this question is easy for you. Okay, now let's move on to the next question. The next question is as follow, which says let sk is equals to limit n tends to infinity. Okay, summation I is equals to 1 to n 1 upon k plus 1 ki to power I. Find summation I is equals to 1 to n k into sk. Okay, we want to find this value. Okay, now how we will do it. Now if we open this thing, whatever they're telling, it is giving a hint. Okay, limit is giving a hint that n tends to infinity, means it is nothing but a sum of infinite terms. Okay, and how we will come to know it is if I just try to open it, 1 to n, it is nothing but k plus 1 power 1 1 upon k plus 1 power 2. Okay, like that. And further on, if I open it, it is nothing but k plus 1 ki power 3. Like that, it will move to infinity. So we got this. Now after getting this thing, then if I do one thing, that it is an infinite series, I have my first term, I have my r, which is r is what, 1 upon k plus 1. Okay, s infinite is nothing but a upon 1 minus r. Okay, n tends to infinity give us the idea, or here you can analyze that it is a GP. So what clicks in your mind, s infinity will be 1 upon k plus 1, this will be 1 minus 1 upon k plus 1, these two will cancel out, which gives me 1 upon k. Okay, so I got sk. S infinity is nothing but sk, because this whole thing is equal to sk. Okay, so we got sk is equals to 1 by k. Now let's find the value. What we value want to find, I is equals to 1 to n k into sk. We got the sk, which is nothing but I is equals to 1 to n k into 1 by k. So if I it gets cancel out, we have I is equals to 1 to n 1, it is nothing but just n. Okay, n times addition of one term. Okay, so we got this value n. Okay, so this question was just application of summation, opening it, analyzing that it is a GP, then seeing n, which gives you a hint of infinite series, and then finding sk value, substituting it, and getting the final answer. That's all it was. Now let's move on to the next question. The next question is this, which says if the sum of the first 6 terms of a GP is 9 times the sum of the first 3 terms, then find the common ratio. Okay, so how we will do it. Okay, so sum of, so S6 is equals to 9 times S3. Okay, find the common ratio. This is nothing but a into r ki power 6 minus 1, and this is nothing but 9 into a into r ki power r. Now they are of same series. Okay, they are telling that sum of first 6 terms, means their r will be same. So this is basic things which children do mistake. Okay, 3 minus 1. Okay, now if we move on, what we have, a r power 5, and here 9 into a r power 2. Okay, now further on, here a will cancel out, which will give me r power 3 is equals to 9. Okay, 5. Okay, this will be 2. Okay, let's check. This will be 6 term, 6 minus 1 5. This will be third term, 3 minus 1 2. Okay, we are doing right. And here we got r is equals to 9. Okay, so r is 3 square. Okay, Now here it is 9, a will cancel out, y, and it is not making a perfect value. It's if okay, it should have making the perfect value. Okay, then it would have been a good question. Okay, let's check again. 6 minus 1, right? 9 into a into 3 minus 1 is 9 times the first. Okay, into, oh shit, we are applying terms formula. Shit, that's why I was thinking why it is not. Okay, so please don't do this mistake. Okay, I got means term after listening term I just forgot that they are telling about sum. Okay, so let's apply the sum formula, which is nothing but a into r power 6 minus 1 upon r minus 1 is what, 9 times a into r power 3 minus 1 upon r minus 1. Okay, now this will cancel out. Okay, what we have, r power 6 minus 1 should be equal to 9 times r power 3 minus 1, which gives you r power 6 minus 1 is equals to 9 r power 3 minus 9. Okay, so what we have, 8 is equals to, okay, 8 is equals to okay, I can see that it is forming a quadratic, r power 6 minus 9 r cube. Okay, if I move it here it will be 8. Okay, should be equal to 0. If I consider let r cube is equals to t, then it is nothing but t square minus 9t plus 8 should be equal to 0, and its root r, t is equals to 8 and t is equals to 1. Okay, now further on, okay, minus 8, okay, and minus, okay, its value are t is equals to 1 and t is equals to 8. Now if I substitute the t value, which is r cube, it should be equal to it, and r cube should be equal to 1, but this is not possible. Why? Because r is not equal to 1. Okay, so we get r is equals to 2 is the answer. Okay, so we got our answer, but the thing what is important, that while reading the question, after reading terms like what happened with me, don't try don't try to use term formula. Okay, after some time I realized that it is I am using term formula. Okay, so after doing this, even after writing the something, oh, okay, so this was the, okay, this was the answer, which is r is equals to 2. Okay, now let's move on to the next question. The basic idea is just applying the thing which they have told and getting the common ratio. The next question, which is this is the next question, which says the largest value of the positive integer. Okay, the largest value of the positive integer k, for which n power k plus 1 divides 1 plus n square till n power 127. Okay, now we want to find the largest value. Now what does it means, that when I divide, okay, this, okay, divided by this whole thing, I should get, okay, means some factor, okay, which power should be, which factor will have the highest power. Okay, so we want to first, this is the term, okay, let's find out its sum. Okay, then we will divide it by this, so summation this, okay, sum of this thing, which is 1 plus n square and so on till n 127. So what we are going to do, the first term, okay, the first term is 1, r is nothing but n, okay, n power what, n, r power n is what, 128. Okay, 128, okay, 128, okay, 128, r is n and n power is 120, because this is 27 term, 127, and this is one term, so 128 minus 1 upon n minus 1. So okay, so after this is this, okay, after this, if I break it further, it has n minus 64, okay, minus 1 into n 64 plus 1 upon n minus 1. Okay, it is being divided by n minus 1. Okay, so okay, it is divided by this, which is n plus 1, okay, divided by this. It is similar to like this. Okay, so this is the similar term. Okay, this term on dividing by this, okay, it has the highest common factor possible. Further on, if I do n raised to 32 minus 1, n raised to 32 plus 1, okay, into n raised to 64 plus 1 upon n minus 1. So the highest n value is n is equals to 64, okay, which is nothing but k. So k is n power 64. So if I divide here, if n power 64, okay, then the common factor means the highest common factor which will be left means highest common factor which will be removed from here will be n power 64 plus 1. Okay, and rest are smaller. Okay, so this was the question. There was nothing. If you don't even understand the question, just try to get the sum and divide it by this. But here after doing the sum you get an idea that it is similar to this, so it is dividing by some general number. Okay, after getting that you can get the highest factor possible after dividing by any number will be this. So k value will be what? Largest value will be 64. If the minimum value, then we would move ahead to the end till whatever, till the least factor which we will get. Okay, we will call it as k value. Okay, so let's move on to the next question. Okay, the next question, but before moving on to the next question, okay, before moving on to the next question, now let's do some things, okay, which are needed to be done now. Okay, we are going to discuss now about geometric mean. What? Okay, we are going to discuss about GM. Okay, geometric mean. Okay, now if you have learned the basic idea in GP that A, B, C are three terms in GP, then what we said, B by A should be equal to C by B. Okay, then you get B square is equals to AC, like this term. Similarly in GP, okay, now GP has nothing to do with, sorry, GM has nothing to do with GP. Okay, when the sequence is GP, it will become just a special case. Okay, nothing great. Okay, so GM has nothing to do with GP in general. Okay, now we will see if the sequence is GP and we want to find GM in that. Okay, then it will be more easier, like in AP. If there was nothing, AM was nothing related to AP, but if the sequence is AP and we want to find AM in that, then it would have been very easy for us. Okay, so if you have understand the idea of AM in AP, then this will be very easy for you to digest. Okay, now let me give you some idea. If I have A1, A2, A3 like that term. Okay, if three term, you easily say that this is the basic thing, that it is nothing but A1 into A2 under root A1 A2, which is this is A1 A2 upon 1 by 2. Okay, now if I tell that there are A1 A2 A3 A4 A5 till AN, okay, then what will be its GM? Its GM will be nothing but whole A1 A2 A3 A4 till what? AN, sorry, this should not be, or 1 by n. Okay, the whole power 1 by, this is not, okay, don't take under root. Okay, 1 by n, number of terms upon 1 by that number of terms power. Okay, like if I take 1 4 6 8 9, now it is not a GP, as I have told, nothing, GM has nothing to do with GP. So GM will be what? If I tell you to find its GM, it will be nothing but 1 into 4 into 6 into 8 into 9 power. These are what? 5 terms, 1 by 5. Okay, so this is the GM. Okay, so you should have an idea that how GM works. Okay, now further on, so we got an idea of GM. Okay, now if you observe, if we take GM in three numbers, okay, A, B, C. Okay, if I tell you to find its GM will be what? AC under root, okay, which is nothing but GM square is equals to CA. Okay, so this thing means B square is equals to CA. Okay, in three terms is similar to this condition. Okay, that's why in our previous lecture I was telling that it is similar to GM. Okay, GM even after this was GP condition, because in three terms GM condition is similar to GP condition. Okay, so don't get confused. Okay, one more thing. Now you have discussed what we have discussed till now. We have discussed that GM has nothing to do with GP. Okay, there can be any number of terms, we can find its GM, number of terms upon 1 by number of terms power. Okay, and if now we will discuss about the second case. Okay, second case, which is this, what it is. Okay, what it is, if, okay, we will discuss here only. Okay, we will discuss here only. Okay, if if the sequence is a GP, then what special thing will happen? That is our curiosity. Okay, now if I tell A1, A2, A3, okay, till AN are in GP, okay, and now that it will be lot easier for you to find GM. Okay, how? There will be two cases, okay, like in it was AP. If n is even, okay, if n is even, there will be two middle terms, no two middle terms. Okay, at what position? At n by 2 comma n by 2 plus 1. Okay, like that. So GM will be nothing but simply what? Under root. What two terms are there? A n by 2 dot A n by 2 plus 1, like this, two terms. That's why 1 by 2. Okay, it is nothing but A n by 2 dot A n by 2 plus 1, the whole power 1 by 2. Okay, so these two terms will, you don't need to find the term, you just need to find the middle terms. Okay, and you can get the GM. That's that easy. Okay, now if second, if n is odd, then you know straightforwardly that one middle term at what position? N plus 1 by 2. Okay, so you know thing. Now here there is only one term. Okay, so its value will be nothing but A n plus 1 by 2. That much easy. Okay, only one term value. If you know the middle term value and it's okay, middle term, you got the GM. That is the method, means most simplest. Okay, if n is odd in and the sequence is GP. Okay, now we will just discuss one more advanced feature of this thing. Okay, now forget this. Okay, just we got this thing. Okay, now one more thing which you need to know, that if I take A1, A2, A3, A4, okay, until AN and AN minus 1, now GM will be how many, means which term can you take here? Okay, the terms should be pair of sum of n plus 1 subscript, like this. I cannot take n plus A1, A2, A3, A4 under upon A1, A2, A3, A4. Okay, this is the speciality which don't know. If I tell that this is GP, no, this is not GP. Why this? Sorry, GM. This is not GM. Okay, why? Because that any two term subscript should give you n plus 1 as it was in AP. So here if I take A1, AN and A2, AN minus 1, then power 4, is this GM? Yes, it is GM. Why? Because the subscript here n plus 1 forming. So they are giving you n plus 1. Okay, so they are giving you n plus, which gives you that GM power 1 by 4. Okay, and this is GM. Okay, this is not GM. Why it is not GM? That the subscript, means these subscripts are not forming n plus 1. Okay, so that is the thing which you need to know, that subscript on adding should give you what? N plus 1. Okay, if they give you n plus 1, then they will give you GP. Okay, and you can take any number of terms. Condition, if I take till here 5, here 6, okay, then how I have to take? A, AN, A2, AN minus 1, A3, AN minus 2, A4, AN minus 3, okay, A5, AN minus 4, the whole power. How many terms I have taken? 1 by 10. Then this is GM. Okay, this is GM. So you must have got the normal condition of GM. Any number of terms, condition, the terms which you take on multiplying upon 1 by n, the term should give you 1 plus n. Okay, that is the basic thing upon number of terms. Okay, so we discussed the cases of GM, special cases when the sequence is a GP, and general GM. Okay, in which we can take any number of term. Condition, the subscript should form n plus 1 and the number of terms to the power 1 by n. Okay, means number of terms 1 upon n. Okay, you have to, that where n is number of terms. Okay, so this is the thing which I wanted to teach you. Okay, GM. Okay, in GM. Okay, now we will do some questions. Okay, and we will and we have completed, means we have completed almost, okay, GP, and we will do questions only now. Okay, so let's move on to the questions back. So the okay okay, I think, okay, let me teach you one more thing. Okay, let me teach you one more thing. The teachers think that they children know it, okay, already, means children already know it. Why they know it? Because they think that they have done this thing in quadratic, so they must have got an idea. Okay, but some means the children who don't have done quadratic, means that much clarity, or they don't have that much information in quadratic equation, they suffer from this thing. What it is? Am is what? Am is what? A plus b by 2. Gm is what? Under root ab. So what I call, if I call denoted by a plus b by 2, and if I denote it by g, ab. If you remember quadratic equation, it was nothing but x square minus a plus b into x, sum of the roots into product of the roots, ab should be equal to 0. Okay, this was the quadratic equation. Now to make it like this, okay, to make it like this should be 2a will be equal to a plus b, and ab will be what? G square will be ab. So if I substitute it here, a square minus 2ax, okay, plus g square should be equal to 0. Now it is a quadratic equation. I can find its root. It will be what? 2a plus minus under root 4a square minus 4g square upon 2. Okay, what it gives me? A plus minus, okay, a square minus g square, and this is what? A value, and similarly this is what? A comma b value. You can take any one. A plus under root a square minus g square, this can be a, and a minus under root a square minus g square, this can be b. Okay, and what a, b, and are this thing. Okay, so this was the thing in GP. Okay, this also gives you a relation between am and gm, but the teachers think that the student already know this. Okay, so but I am teaching it so that you should be alert using, okay, you should be conscious. Okay, and you don't seem like surprised that what has came in this question. Okay, it should be like, yes, I know it, and I can deal with it. Okay, I can just, you need to just calculate and just use your brain, okay, to tackle the question. Now let's move on to the questions now. Okay, now let me give you a quick summary of what we did. Am was a plus b by 2, gm was ab under root ab, a is equals to a plus b by 2. I called it gm as g, am as a. And if you remember, a plus b was what? Sum of the roots. A into b is product of the root ab. So I move under root that side, which gives me g square. Okay, which gives me g square, and a plus b is 2a. I substituted that in the general quadratic equation, x square minus 2a x plus g square equal to 0. I got x is equals to 2a plus minus under root 4a square minus 4g square upon 2. And then I got what? Means children, what they do, that they keep it as x only. No, don't do that. Just remember that it is nothing but a and b. Okay, that will be useful in question, because you don't know what is x. Okay, that is the, these are roots, fine, but you should know that these x are just the value of a and b. Okay, sum of the roots mean roots are what? A and b. Okay, the children are curious, what is the root, what is the root? Yes, the roots are a and b. Okay, so you can, I have taken any a value, a plus under root a square minus g square. Okay, you can further simplify it as a plus g, a minus b, doesn't matter. Okay, so this was the thing. Okay, relation between quadratic and sequence series. Okay, and if further relations comes, I will explain it in the sequence, okay, in the next lectures. Okay, so till then, okay, now let's move on to the questions. The question is as follow. This question is as follow. Okay, the question says, if you have read, if g is the geometric mean of x and y, then prove that 1 upon g square minus x square plus 1 upon g square minus y square is equal to 1 upon g square. How we will prove this? Now if g is the, okay, g should be equal to under root xy, right guys? This, if it is geometric mean, its value should be under root xy. So g square will be what? G square will be nothing but xy. Now let's substitute the value and get, and see what we can get. Okay, and let's see what we can get. Okay, so now let's substitute the value of g square. Okay, what we have? 1 upon xy minus x square plus 1 upon xy minus y square. Okay, if I multiply it both the side, what I have? Xy minus y square plus xy minus x square upon this thing, xy minus x square into xy minus y square. Further on, here you have 2xy minus y square minus x square, and here you have what? Here you have x square y square x y cube, okay, and here you have x cube y, similarly plus x square y square, okay. This thing you have here, okay. Now let's calculate it further, okay. So what we can do here, if I take minus common, it is nothing but x plus x minus y power the whole square, okay, x minus y the whole square. And here what we can do, okay, if I take xy common from whole, okay, xy common, then what I have xy, okay, this sorry let's just calculate it. It is 2x square y square, okay, nothing but xy cube minus x cube y, okay. So we are done with this thing, okay. Now let's x minus y the whole square, okay, upon this thing. If I take s comma y common, okay, minus also, because here we have to form like this, okay, in the bottom, okay. And I can see that it is forming a square if I just do a little manipulation like taking xy common. So if I take xy common, okay, what I see is xy common, okay, what I have 2xy minus, okay, minus 2xy plus y square plus x square, okay. So I got this thing. Now minus will eliminate, be eliminated, and this thing is nothing but x minus y the whole square. So I got xy, which is nothing but, if you remember, xy was what? 1 upon g square. So we have proved, okay, hence proved, okay. The question was just on basis of calculation, and just you know the GM, okay, just to make you a little comfortable with GM, okay. Now let's move on to the next questions, okay. The next question is this, okay. This is again not a big level question, okay. This question is just to make you comfortable, okay, while using GM, okay. So it is telling insert for GM, okay. I have not taught you insertion, okay, let me teach you, then we will do this thing, okay. Now how we insert GM, okay, like in AP, okay. Now we will discuss GM insertion, okay, GM insertion, okay. We will do GM insertion, okay. Now if I tell there are A and AB two terms, okay, I want to insert a GP, okay, G1, okay. Then when you insert any GM in between two number, the number automatically form a GP, okay, automatically form a GP. Now how we will form a GM, okay, how we will form a GM, how we will do insertion of GM. For that, if I take one example, if I have A and here I have B, okay, if I take it G1 G2, okay, till Gn, okay, and GM are inserted between A and B, okay. If I call it as T1, this as T2, this as T3, okay, this will be what, okay, this will be what, Tn, okay, and this will be what, this will be what, T, okay, Tn plus 1, okay. So Tn plus 1. So if I write the position of this term Tn plus 1, it is nothing but A into R power 1 upon n plus 1, okay. So Tn plus 1 will okay, Tn plus 1, okay, it should be okay, okay. This term is Tn plus 1, okay. So 1 2, if I put 1 it is, if it is 2, okay, 1 it is 0, okay. And this is what, if it is n term, okay, if it is n term, okay, then it is, okay, it is n plus 2 term total, and this term will be what, n plus 2, okay. For T n plus 1, for 1 it is 0, okay. For T n plus 1, this will be T n plus 2, okay, because in between there are n terms, okay. This will be 1, this will be 2, and this will be T n plus 1, and this will be T n plus 2, okay. So this B term will be what, B term will be nothing but n plus 2 term, okay. So T n plus 2 will be T n plus 2 minus 1, which will give me, and this T n plus 2 term is nothing but B, and this is a r की power 1 by n plus 1. So what value of r we get? b by a power, okay, b by a upon n plus 1, okay, b by power upon n plus, okay, b by power, this is 1 upon r, okay, why I am using 1 upon r, okay, r n plus 1, this is not 1, okay, this is nothing but n plus 2 minus 1, this is like the n plus 2 I want to find. This is a r power n plus 2 minus 1, and this is b, this is a r power n plus 1. We get b by a is equals to 1 upon n plus 1, okay, like that, and here we got r, okay, so we got the r. So our r is b by a 1 upon n plus 1, okay, so we got our r. Now if you see, if I tell that it is a, then g1 is nothing but ar, g2 is nothing but ar square, okay, g3 will be nothing but ar cube. So you can find any gm just by multiplying it by that term into r power, okay, okay, a into that power will be of r will be that term position, okay, so it makes our job easy, okay. Now further on, there is a direct method also, okay, like if we want to calculate some gm, okay, like if I want to calculate some g2, okay, it will be what, a into b r power what, 1 upon n plus 1, okay, r is what, b by a, and this is what power, 2 power, okay, so n plus 1 by 2 by n plus 1, okay, like this. Further if you see, what we can do, a into b square upon a square, okay, upon 1 by n plus 1, and if I bring this inside, n plus 1 into b square, okay, upon a square, this will be what, 1 upon n plus 1, okay. Here you can see what we are getting, this will go up and we will get a n minus 1 into b की power 2 upon 1 upon n plus 1. So from this, what we can derive to find the any term gm, okay, instead of this method, direct method, okay, r cube, we can directly find any gm using what, if gk is any gm, okay, it is nothing but a n plus 1 minus k b power k 1 by n plus 1, okay, you can directly find the any gm in between gm, okay. So what was that, we take two terms, we take n terms between them, we located them, that if it is n term, this will be 1, this will be 2, which will give me a total number of term n plus 2, and this is n plus 2, so n plus 2 is b, so we substituted here b, and a into r power n minus 1 is the formula of term, okay, and this is n plus 2 minus 1, which is gives me n plus 1, so b by a power n plus 1, okay, b by a power n plus, sorry, okay, so b by a power 1 upon n plus 1 is equals to r, so we got this thing. Now further on, we came to know that g1 is nothing but a into r, g2 is nothing but ar square, and g cube into ar cube, okay. So if we take, okay, between two terms, we came to know that we can find any gm using the general by finding r is what, b by a power 1 upon n plus 1, okay, this is the general r, okay. If we came to know r, we can get any gm directly, that is g1 is equals to ar, g2 is equals to ar square, g3 is equals to ar cube, okay, that term position into a of that term r power, okay, that r power, okay. Further on, we wanted to find exact formula for getting any particular gm, okay, if I want to find g4, g5, like that, okay. So how we will find that, we generated a general formula by solving this, okay. If I want to find g2, I multiplied a into r, that power, okay, 2 by n plus 1, okay, I took a inside, which gives me b square upon a square into a n plus 1, we took a square inside, b square upon a square. Further on, we just what we got, a is nothing but a and a power n minus 1 b square, the whole upon 1 upon n plus 1, okay. And then we created a general gk formula, which is nothing but a n plus 1 minus k b power k, okay, the whole up 1 upon n plus 1, okay. This is the general kgm, okay, which we want to find, okay. So we got a direct formula of getting any particular gem. Now we can continue with that question, okay. Hope you have understand, okay. The formula derivation doesn't matter, Okay, the main important ingredient in this, that you need to remember this r, because in some question you will be able to easily get r, while in some question you may not be able to get easily r, but you will have some nice value of a, b and n, and so that you can use a to power n plus 1 minus k into b power k, the 1 upon n plus 1, the whole 1 upon n plus 1, directly to get any particular gm. Okay, so we are done with this thing. Okay, insertion of gm. But remember, when we insert any gm, okay, between two numbers, the sequence become a gp. Okay, that is the crucial part. Okay, you should remember this point. Okay, so now let's continue with our questions which we were doing. Okay, so let's continue, which tells the second question. Okay, the second question which says insert 4 gm between 2 and 486. Okay, so I came to know that a is nothing but 2 and b is nothing but 486. Okay, so we came to know a and b. Okay, so we have a is equals to 2 and b is equals to 486. Okay, now we want to insert 4 gm. Okay, but the basic thing is, let's try to find out r. Okay, a is what, b by a power 1 upon n plus 1. Okay, this is nothing but 486 by 2 the power 1 by, how many gm you want to insert, that is the important, 4. So 4 plus 1. Okay, here you put the number of gm which you want to insert. Okay, so 486, this is 243 upon 1 by 3. Okay, so 243. Okay, 243. Okay, this is what, 4 plus 1 5. Okay, this is 5. Okay, so if I move 5 that side, it is nothing but r power 5, and here it is what, 243. Okay, and here if you observe, this 243 is nothing but 3 power 5. Okay, so we got r is equals to 3. Okay, now we got r is equals to 3. Now our job is done. We don't need to go that formula a n plus 1 minus k upon b power k, the whole upon 1 upon n plus 1. You don't need to get directly to that formula. You can directly solve, which is how you want to find 4 gm. G1 is nothing but a into r, G2 will be nothing but a into r square, G3 is nothing but a into r cube, and G4 is nothing but, you want to insert 4 gm, 4. Okay, now we are done with this problem, question number 2, and we will move on next. Okay, the next question says, if the am and gm, okay, between the two numbers are in the ratio m is to n, then prove that the number are in the ratio. Okay, we want to prove that the number are in the ratio this. Okay, now if I denote am by a and gm by g, okay, they are telling that a by g is nothing but m by n. Okay, then can I say that it is equal to lambda? So a will be what, m into lambda, and g can be n into lambda. Okay, similarly. Okay, now if you remember the formula which we have derived using the quadratic equation. Okay, how we will able to click that? Okay, prove that the number are in the ratio. Okay, we want to tell that this means this okay, this m by n, okay, this gm by am, okay, are between 2m, okay, between two numbers, and these numbers which it is between, okay, it is in the ratio like this. Okay, but if you remember, we have some x is equals to a plus minus under root a square minus g square like thing. Okay, in when we were deriving the roots. Okay, so doesn't it remind you of the quadratic equation roots? So we have found a relation. Okay, so here a is what, if I say that a and b are the two numbers. Okay, a and b are the two numbers, so a will be equal to what, a plus minus under root a square minus g square plus minus. Okay, so a will be what, a I can replace by m into lambda plus minus m square into lambda square minus n square into lambda square. Similarly b, okay, and this can act as a both a and b because plus minus. Now if I divide a by b, okay, a by b, okay, what I have, m into lambda plus under root m square lambda square minus n square lambda square, similarly upon m into lambda minus under root m square lambda square minus plus n square lambda square, sorry, minus. Okay, minus. Okay, so here you can see that lambda will cancel out, which will give me finally this answer. Okay, the main thing here was am and gm are between two numbers. Okay, and the ratio is like m by n. Okay, if what they're telling, you want to find the ratio of the numbers. Okay, and you know that am gm has two roots. Okay, the quadratic equation has two roots. Okay, And if you remember, the quadratic roots had a and b, and if you remember more, a and b are nothing but just a tool to get gm and am. So these two numbers are nothing but am and gm. Okay, it means these two numbers are nothing but the numbers which mean them am and gm are there. So you can use the quadratic formula. Okay, instead of getting this long derivation, you can be easily to get that solution. Okay, that was the best application of the quadratic and okay, sequence and series. Okay, so hope you have understand this thing. Now let's move on to the next question. Okay, the next question is nothing but this question. Okay, the next question is nothing but this question, which says if a is the am and b, okay, a is the am of b and c, okay, and the two geometric means are g1 and g2, then prove that g1 cube plus g2 cube is equals to 2abc. Okay, now a is what? A is our am, so a will be surely b plus c by 2. You can say that, right? Now similarly there are two geometric means, okay, g1 and g2 between what? B and c, g1 and g2. Okay, if I consider these three terms in gp, and similarly if I consider these three terms in gp, then cannot I write g square is equals to bg2, and similarly I can write g2 square is equals to g1c. Okay, can I write this thing? Yes, I can surely write this thing. Okay, now what I want? g1 cube and g2 cube. So if I multiply it again by g1, okay, what I have? G1 cube should be equal to b into g2 into g1. Similarly g2 cube will be nothing but g1 into g2 into c. Okay, now if I add this, what I get? G1 cube plus g2 cube is nothing but b, okay, b plus c into g1 g2. I took g1 g2 common, and b plus c is nothing but b plus c from here is nothing but 2 into a. So if I put 2 into a, g1 g2, okay, g1 and g2, okay, 2abc. Okay, it this is okay, this is okay, you can prove this also. Okay, how you will prove this? Okay, how you will prove this? You know that g1 g2 is what? Under root a into b into c. Okay, to a, I think this question is something. Okay, this question is what? 2 into a into g1 into g2 to prove. Okay, this is what they want to prove. Okay, but let me check the question. Okay, again. Okay, so tn plus 1 will okay, tn plus 1, okay, it should be, okay, it should be, okay, this term is tn plus 1. Okay, so 1 2, if I put 1 it is, if it is 2, okay, 1 it is 0. Okay, and this is what? If it is n term, okay, if it is n term, okay, then it is, okay, it is n plus 2 term total, and this term will be what? n plus 2. Okay, for t n plus 1, for 1 it is 0. Okay, for t n plus 1 this will be t n plus 2. Okay, because in between there are n terms. Okay, this will be 1, this will be 2, and this will be t n plus 1, and this will be t n plus 2. Okay, so this b term will be what? B term will be nothing but n plus 2 term. Okay, so t n plus 2 will be t n plus 2 minus 1, which will give me, and this t n plus 2 term is nothing but b, and this is a, r की power 1 by n plus 1. So what value of r we get? B by a power, okay, b by a upon n plus 1. Okay, b by power upon n plus, okay, b by power, this is 1 upon r. Okay, why I am using 1 upon r? Okay, r n plus 1, this is not 1. Okay, this is nothing but n plus 2 minus 1. This is like t n plus 2 I want to find. This is a, r power n plus 2 minus 1, and this is b, this is a, r power n plus 1. We get b by a is equals to 1 upon n plus 1. Okay, like that, and here we got r. Okay, so we got the r. So our r is b by a 1 upon n plus 1. Okay, so we got our r. Now if you see, if I tell that it is a, then g1 is nothing but ar, g2 is nothing but ar square. Okay, g3 will be nothing but ar cube. So you can find any gm just by multiplying it by that term into r power. Okay, a into that power will be of r will be that term position. Okay, so it makes our job easy. Okay, now further on there is a direct method also. Okay, like if we want to calculate some gm. Okay, like if I want to calculate some g2. Okay, it will be what, a into b r power what, 1 upon n plus 1. Okay, r is what, b by a, and this is what power, 2 power. Okay, so n plus 1 by 2 by n plus 1. Okay, like this. Further, if you see what we can do, a into b square upon a square. Okay, upon 1 by n plus 1. And if I bring this inside, n plus 1 into b square, okay, upon a square, this will be what, 1 upon n plus 1. Okay, here you can see what we are getting. This will go up and we will get a n minus 1 into b ki power 2 upon 1 upon n plus 1. So from this what we can derive to find the any term gm. Okay, instead of this method, direct method, okay, r cube, we can directly find any gm using what, if gk is any gm. Okay, it is nothing but a n plus 1 minus k b power k 1 by n plus 1. Okay, you can directly find the any gm in between gm. Okay, so what was that, we take two terms, we take n terms between them, we located them, that if it is n term, this will be 1, this will be 2, which will give me a total number of term n plus 2, and this is n plus 2, so n plus 2 is b, so we substituted here b, and a into r power n minus 1 is the formula of term. Okay, and this is n plus 2 minus 1, which is gives me n plus 1, so b by a power n plus 1. Okay, b by a power n plus, sorry, okay, so b by a power 1 upon n plus 1 is equals to r. So we got this thing. Now further on we came to know that g1 is nothing but a into r, g2 is nothing but ar square, and g cube into ar cube. Okay, so if we take, okay, between two terms, we came to know that we can find any gm using the general by finding r. R is what, b by a power 1 upon n plus 1. Okay, this is the general r. Okay, if we came to know r, we can get any gm directly, that is g1 is equals to ar, g2 is equals to ar square, g3 is equals to ar cube. Okay, that term position into a of that term r power. Okay, that r power. Okay, further on we wanted to find exact formula for getting any particular gm. Okay, if I want to find g4, g5, like that. Okay, so how we will find that, we generated a general formula by solving this. Okay, if I want to find g2, I multiplied a into r, that power, okay, 2 by n plus 1. Okay, I took a inside, which gives me b square upon a square into a n plus 1. We took a square inside, b square upon a square. Further on we just what we got, a is nothing but a and a power n minus 1 b square, the whole upon 1 upon n plus 1. Okay, and then we created a general gk formula, which is nothing but a n plus 1 minus k b power k. Okay, the whole 1 upon n plus 1. Okay, this is the general kgm. Okay, which we want to find. Okay, so we got a direct formula of getting any particular gem. Now we can continue with that question. Okay, hope you have understand. Okay, the formula derivation doesn't matter. Okay, the main important ingredient in this, that you need to remember this r, because in some question you will be able to easily get r, while in some question you may not be able to get easily r, but you will have some nice value of a, b and n, and so that you can use a to power n plus 1 minus k into b power k, the 1 upon n plus 1, the whole 1 upon n plus 1, directly to get any particular gm. Okay, so we are done with this thing. Okay, insertion of gm. But remember, when we insert any gm, okay, between two numbers, the sequence become a gp. Okay, that is the crucial part. Okay, you should remember this point. Okay, so now let's continue with our questions which we were doing. Okay, so let's continue, which tells the second question. Okay, the second question which tells insert 4 gm between 2 and 486. Okay, so I came to know that a is nothing but 2 and b is nothing but 486. Okay, so we came to know a and b. Okay, so we have a is equals to 2 and b is equals to 486. Okay, now we want to insert 4 gm. Okay, but the basic thing is, let's try to find out r. Okay, a is what, b by a power 1 upon n plus 1. Okay, this is nothing but 486 by 2 the power 1 by how many GM you want to insert, that is the important. 4, so 4 plus 1. Okay, here you put the number of GM which you want to insert. Okay, so 486, this is 243 upon 1 by 3. Okay, so 243. Okay, 243. Okay, this is what, 4 plus 1, 5. Okay, this is 5. Okay, so if I move 5 that side, it is nothing but r power 5, and here it is what, 243. Okay, and here if you observe, this 243 is nothing but 3 power 5. Okay, so we got r is equals to 3. Okay, now we got r is equals to 3. Now our job is done. We don't need to go that formula a n plus 1 minus k upon b power k the whole upon 1 upon n plus 1. You don't need to get directly to that formula. You can directly solve, which is how you want to find 4gm. G1 is nothing but a into r, g2 will be nothing but a into r square, g3 is nothing but a into r cube, and g4 is nothing but, you want to insert 4gm, 4. Okay, now we are done with this problem, question number 2, and we will move on next. Okay, the next question says, if the am and gm, okay, between the two numbers are in the ratio m is to n, then prove that the number are in the ratio. Okay, we want to prove that the number are in the ratio this. Okay, now if I denote am by a and gm by g, okay, they are telling that a by g is nothing but m by n. Okay, then can I say that it is equal to lambda? So a will be what, m into lambda, and g can be n into lambda. Okay, similarly. Okay, now if you remember the formula which we have derived using the quadratic equation, okay, how we will able to click that? Okay, prove that the number are in the ratio. Okay, we want to tell that this means this okay, this m by n, okay, this gm by am, okay, are between 2m, okay, between two numbers, and these numbers which it is between, okay, it is in the ratio like this. Okay, but if you remember, we have some x is equals to a plus minus under root a square minus g square like thing. Okay, in when we were deriving the roots. Okay, so doesn't it remind you of the quadratic equation roots? So we have found a relation. Okay, so here a is what, if I say that a and b are the two numbers. Okay, a and b are the two numbers, so a will be equal to what, a plus minus under root a square minus g square plus minus. Okay, so a will be what, a I can replace by m into lambda plus minus m square into lambda square minus n square into lambda square. Similarly b, okay, and this can act as both a and b because plus minus. Now if I divide a by b, okay, a by b, okay, what I have, m into lambda plus under root m square lambda square minus n square lambda square, similarly upon m into lambda minus under root m square lambda square minus plus n square lambda square, sorry, minus. Okay, minus. Okay, so here you can see that lambda will cancel out, which will give me finally this answer. Okay, the main thing here was am and gm are between two numbers. Okay, and the ratio is like m by n. Okay, if what they're telling, you want to find the ratio of the numbers. Okay, and you know that am gm has two roots. Okay, the quadratic equation has two roots. Okay, and if you remember, the quadratic roots had a and b, and if you remember more, a and b are nothing but just a tool to get gm and am. So these two numbers are nothing but am and gm. Okay, it means these two numbers are nothing but the numbers which mean them am and gm are there. So you can use the quadratic formula. Okay, instead of getting this long derivation, you can be easily to get that solution. Okay, that was the best application of the quadratic and okay, sequence and series. Okay, so hope you have understand this thing. Now let's move on to the next question. Okay, the next question is nothing but this question. Okay, the next question is nothing but this question, which says if a is the am and b, okay, a is the am of b and c, okay, and the two geometric means are g1 and g2, then prove that g1 cube plus g2 cube is equals to 2abc. Okay, now a is what, a is our am, so a will be surely b plus c by 2. You can say that, right? Now similarly, there are two geometric means, okay, g1 and g2 between what, b and c, g1 and g2. Okay, if I consider these three terms in gp, and similarly if I consider these three terms in gp, then cannot I write g square is equals to bg2, and similarly I can write g2 square is equals to g1c. Okay, can I write this thing? Yes, I can surely write this thing. Okay, now what I want, g1 cube and g2 cube. So if I multiply it again by g1, okay, what I have, g1 cube should be equal to b into g2 into g1. Similarly, g2 cube will be nothing but g1 into g2 into c. Okay, now if I add this, what I get, g1 cube plus g2 cube is nothing but b. Okay, b plus c into g1 g2. I took g1 g2 common, and b plus c is nothing but, b plus c from here is nothing but 2 into a. So if I put 2 into a, g1 g2. Okay, g1 and g2. Okay, 2 abc. Okay, it this is okay, this is okay, you can prove this also. Okay, how you will prove this? Okay, how you will prove this? You know that g1 g2 is what, under root a into b into c. Okay, 2a. I think this question is something. Okay, this question is what, 2 into a into g1 into g2 to prove. Okay, this is what they want to prove. Okay, okay, but let me check the question. Okay, again. Okay, but let's try to prove this thing also, which is 2abc. Okay, okay, but the question was 2a g1 into g2. That is what we have to prove. Okay, if you remember, it is between this term. Okay, then if g1, if I consider only g1, it is between b and c, then I can write under root bc. Similarly, if I consider g2, I can write under root bc. Okay, okay, so okay, let me think. Okay, g1 and g2. Okay, the geometric means will be different. Okay, sorry, we have to think a little more. Okay, our process, we have to change it. Okay, we have to. Okay, let's prove this thing also, which is 2abc. Okay, okay, so let's prove that also. Okay, which is 2abc. How we can prove? Okay, okay, let's do this thing. Let's find the common ratio. It's g1 and g2. Okay, let's, what is the common ratio of this, which will be, if it is between b and c, okay, then it will be c by b, the whole upon 1 upon. Okay, how many gm are there? 2. So 2 plus 1. Okay, so c by b power 1 by 3. Okay, so we got the common ratio, and g1 will be what? G1 is second term, it will be nothing but a into r, which is nothing but b into c by b power 1 by 3. Similarly, g2 will be nothing but a into r square, which is nothing but b into c by b power 2 by 3. Okay, now if I cube it, I get g1 cube is nothing but b cube. Okay, b cube into c by b, which gives me b square c. Okay, similarly, g2 cube is nothing but b. Okay, this is square also. Okay, this is nothing but, here you will get b cube, and here you will get c square b square. Okay, so you get b into c square. Okay, so if I just add them, means g1 and g2. Okay, g1 cube plus g2 cube. Okay, if I add them, what I have, b square c plus bc square. Okay, if I get b c, if I take common. Okay, okay, bc if I take common, I have b plus c. Okay, which is nothing but b plus c is what, 2a. So 2abc. So we have proved this also. Okay, so how we got a hint? We got a hint that let's just try to locate the position of g1 and g2 and see what we can get. Okay, then we located that. How we can get g1 and g2? By finding the common ratio. Although this was more tougher than that. Okay, because you need to, means, manipulate here instead of doing this thing. Okay, getting the ratio and locating g1 and g2. Okay, so I find it more difficult, so I took this one instead of leaving, but by mistakenly I took this one. Okay, write the proof of this. Okay, so I proved both of them. Okay, in some books you will see this, in some books you will see this. Okay, so let's move on. Okay, to the next question. Question number 4 we have done. This is question number 5. Okay, this is question number 5, which says if the first and the second term of a GP, okay, are x power minus 4 and x power n respectively. If x power 52 is the 8th term, then find the value of n. Okay, so I got t1 is equals to a is equals to x to minus 4. Similarly, my second term t2 is nothing but x to the power n. Can I get the common ratio? Yes, sure. N power upon x power minus 4, which gives me a common ratio x power n plus 4. Okay, now I want to find the 8th term. 8th term is nothing but a into r power 8 minus 1 means 7, which gives me 8th term is what, x power 52. A is what, my x power minus 4 into r is what, x power n plus 4 into 7, which gives me, here this power will add on, which give me 56. This will be what, x power 7n 28. If I equate the term, 56 minus 28 should be 7n, and what we get, okay, what we get, 56 minus this 28. Okay, 28, we are getting 28 is equals to 7n, which gives me n is equals to nothing but 4. Okay, so we got n is equals to 4. That is what we needed to find out in this question. It was nothing but just the direct application of the things. Okay, it will make you more comfortable in GP. Okay, geometric progression. The sixth question is, if a comma b comma c, if a comma b and c are respectively the pth, qth and rth term of a GP, then show that q minus r log a plus r minus p log b plus p minus q log c is equal to 0. How we can prove this? Okay, now a into r power p minus 1, this is the a term. Okay, let me take it as capital A and capital R. Okay, b is nothing but a into r power q minus 1, c is nothing but a into r power r minus 1. Now let's substitute these values. Okay, let me take the next page. Okay, what we have q minus r is equals to log a r. Instead of a, I will replace it by this. Similarly, r minus p into log b, what I have, a r q minus 1 in log c, what I have, p minus q into log a r minus 1. Okay, so what we can do, let's expand the log. What I have, q minus r here. Okay, I will do one and the next you can understand. It is nothing but log a. Okay, log a plus p minus 1 into log r. How I did it, I broke it into multiples, then I took it here, p minus 1. Okay, like that. Similarly, here it will be r minus p, and this will be what, log a plus q minus 1 into log r. Okay, here will be what, p minus q, here will be what, log a plus r minus 1 into log r. So we got the whole thing. Now we will use our aptitude thing. Okay, here to reduce our calculation, log a into p, log a into minus r, log a into plus r, log a into minus p minus q. Okay, you can see these all terms are getting cancelled out, so why calculate them? Okay, similarly, now let's jump onto the calculation of this, q minus r into p minus 1. Okay, this term is same in all, so I can take it as common. Similarly, r minus p into q minus 1 into log r, I have taken common, p minus 1 into, okay, p minus q into r minus 1, the whole what we have taken common, log r. Okay, now if you see, it is nothing but qp minus q minus rp plus r rq minus r minus pq plus p pr minus p minus qr plus q. Okay, this thing into what, log r. This is just to make you comfortable with some calculations. If you see qp r q, yes, q is here, rp r okay, pp. Okay, all are cancelling out, we get this equal to 0. Okay, so we have proved this thing. Okay, that was nothing but just writing the terms, substituting them using the logarithmic basic properties, and then getting the answer. Okay, so we are done with question number 6th, 5th and 6th. Okay, let's move on to the next question. Okay, the question number 7th is as follow. Okay, the question number 7 says if P comma Q and R are in the AP, okay, then are in AP, then show that the Pth, Qth and Rth term of any GP are in GP. Okay, any term, okay, Rth term of any GP are in GP. So let's assume that it is a GP. Okay, Pth and Rth term are in a GP. So P and Q. So one thing I can write that Q is equals to P plus R. That I can surely write. Okay, so the Rth term, okay, TR term is nothing but A into R power what? R minus 1. Okay, let me take it as capital R. Okay, so this is the thing. Now P and Q and R are show the P, T and R terms of any GP are in GP. So similarly we can write TP is nothing but, okay, TP is nothing A into R power P minus 1 and TQ is nothing but A R power R minus 1. Okay, we have done that. It is nothing but Q. Okay, Q minus 1. Okay, so we got this thing. Okay, now if it is in GP, okay, these three things are in GP, then this A R P minus 1, okay, P Q R, okay, this thing, okay, sorry, this thing A R Q minus 1, the whole square should be equal to what? A R R minus 1 plus A R P minus 1. Okay, so if it is equal, so what I can write? A square into R power 2Q minus 2, it should be equal to 8. If I take A common, okay, A common, it is what? R power R minus 1 plus R power P minus 1. Okay, A square. Now 2Q, okay, 2Q minus, if you remember this is in AP, okay, Q is nothing but, so 2 times P is what? 2 times Q is what? You can write it as A square, R power 2Q is what? P plus R minus 2, and here if I add them, it is nothing but A power 2, okay, into R power R plus P minus 2. Okay, oh sorry, it is product. Okay, it is product. Okay, because we are proving GP, so this square, it should be the product of this, so A square should be the product of this, and here it is equal, so they are equal, means they are in GP. They are in GP. So P and Q are terms and AP, and any term P with Q with R a term of any GP, okay, it is in GP. So we have proved that. Okay, even though you don't understand the language of the question, okay, you must understand the basic thing that you have to prove this thing. Okay, you know the basic condition of P square, okay, is equals to QR. Okay, the basic condition of GP like AP. You have used the basic things of AP and just used to a little manipulation, and then you got our answer. Okay, so now we will move on to the next question, which is question number 8. Okay, so what it says, if A, B, C, D are in GP, prove that A power n plus B power n, comma B power n plus C power n, comma C power n plus D power n are in GP. Okay, now they are in GP, so I can consider them as A, B as AR, C as AR square, and D as AR cube. Okay, like this. Now if you see this, it is A power n plus A n R power n. If I take A n common, I get 1 plus R power n. Similarly, this is my first term. Similarly, this second term will be what? A power n into R power n, and this will be A power n into R power 2n. If I take from this A power n into R power n common, I have 1 plus R power n left. Okay, now similarly in the third term, which is A power n R power 2n, A power n R power 3n. Okay, if I take A power n and R power 2n, what I have? 1 plus R power n. Now you can clearly see from here all the things are coming equal. Okay, see, if I take any two term ratio, if these two term, okay, one term is this, one term is this, and one term is this. If I take 2 by 1, what I get? R by n. 3 by 1, what I get? R by n. This n will only 1 R by n will be left. So it again proved that they are in GP. They are in GP. So don't get scared whenever you see n power, just try to take GP like that. Okay, now one doubt can be why you didn't take a by r a. Okay, here you means 4 terms. Okay, a by r cube, a by r square. Okay, like that. Why didn't you took that? Because here there is no, they have not given you any hint of product thing. Okay, so there was nothing making any sense of using that. Instead you should go with basic if there is no product application. Okay, why do we consider terms? Because in product they will cancel out, while in AP the sum will in sum they cancel out. Okay, so let's move on to the next question. The next question is this question. Okay, question number 9. The question number 9 says if TR denotes the rth term of a GP for r is equals to 1, 2, 3. If for some positive integer m and n we have Tm is equals to 1 upon n square and Tn is equals to 1 upon m square, then find the value of Tm plus n by 2. Okay, so we want to find the value of this. Okay, so Tm is nothing but a r power m minus 1, which is nothing but 1 upon n square is a r power m minus 1, and similarly 1 upon m square is nothing but a r power n minus 1. This is first, this is second. Now we want to find Tm plus n by 2, which is nothing but a r power m plus n by 2 minus 1. Now can I create this thing from these two? Yes, if I multiply this m square into n square, I get a into r power m plus n minus 2. Okay, and if it is a whole square, I can write it 1 upon m into n the whole square, a into this will be a square. Okay, this will be m plus n minus 1. If I move the square that side, I get 1 by n. M is nothing but a into r power m plus this was 2. This is nothing but m plus n by 2 minus 1. Okay, these two will get reduced by the 2 here. Okay, while this will be left. So doesn't it seem like Tm plus n by 2? So it is nothing but m by n. So we got our answer, which was nothing, it was just basic manipulation question. Okay, and using the Tn formula. Okay, it just gives you, means it just improves your understanding of the chapter, makes you a little comfortable in GP. Okay, so that's why we are doing so much question. Okay, now question number 10. If a, b, c and d are in GP, show that this ab plus bc plus cd the whole square is equals to a square plus b square plus c square into b square plus c square plus d square. Okay, this thing how we can prove? Okay, now if I consider again, here I consider ar square, ar cube. Okay, now what I can get from here? This is nothing but a into ar square, ar into ar square, ar square into ar cube the whole square, which gives me, if I take a square common, this will become a4. If I take r square common, this will become r by 4. Okay, wait, a into r, this will be only ar. Okay, this will be only ar and this will be ar into a square. Okay, right, a cube. Okay, so a into ar into, okay, so this will be a square. We will take only r common, so there will be 1 into r square plus r into 4. Okay, the whole square. Okay, so what we have, a raised to 4 r square into 1 plus r square plus r raised to 4 the whole square. Okay, now what we can do here it will be what, a square plus a square into r square plus a square. Okay, a square into what, it is what, r square, so it will become 4. Similarly here it will be what, a square r square into a square r raised to 4, a square, okay, in r raised to 6. Okay, because it is 3. Okay, now here if I take out a square from here and a square from here, I get a raised to 4. If I take here, I cannot take anything common r, here I can take r square. So if I take r square common, what I get, 1 plus r square plus r raised to 4 into 1 plus r raised to r square plus r raised to 4. So it is nothing but, this is a raised to 4 r square into 1 plus r square plus r raised to 4 the whole square. So these two are equal. Okay, if you observe, these two are equal. Okay, these two are equal. So we have proved that. Okay, we have proved this thing which they were telling to show that. Okay, this is equal to this and similarly this is equal to c, so they both are equal. Okay, so let's move on to the next question. The next question is question number 11. okay, which says the sum of the three numbers in GP is 56. If we subtract 1, 7, 21 from these numbers, okay, okay, a number in that order, okay, in this order, if we subtract, we obtain an arithmetic progression, find the numbers. Okay, now the sum, let's take the numbers a, ar and ar square. Why we are taking? Because there is no product application. Okay, so what we have, the sum of the three numbers, if I take a common, 1 by r plus 1, okay, this is nothing but 56. Okay, similarly if I subtract a minus 1, similarly ar minus 7, ar square minus 21. Okay, okay, subtract this thing. Okay, we got this is our terms. Okay, these are our three terms. Okay, after subtracting, okay, subtract these, they are in arithmetic progression. Okay, so 2 into ar minus 7 should be equal to what? A minus 1 plus ar square minus 21. What we get? 2 ar minus 7 to the 14, which is nothing but a plus ar square minus 22. Okay, and here if you notice what we have, ar square minus 2ar. Similarly 22, if I move it here, it will be what? It will be 8. Okay, minus 8 plus a should be equal to 0. Okay, now if I move 8 that side, ar square minus 2ar, okay, should plus a should be equal to 8. Okay, so we got this thing. Now here we have, okay, let's simplify this. A into 1 plus r square plus 1 plus r square plus r, okay, plus r is equal to 56r. So what we have, a, okay, a plus ar square plus ar minus 56, okay, 56r. Okay, so what we can do, okay, this is equal to 56r. okay, it is equal to 1 upon r. Oh, sorry, it is not what we are doing, shit. This is what? A plus ar plus ar square is equal to 56. If I take a common, I have 1 plus r square is equals to 56. Okay, now okay, it can make, we can make it like this: a r square minus a, okay, r 2r plus 1 is equals to 8. Okay, so we are making it like that, but here it is minus 2r and here it is r. Okay, so but 8 7 is 56. Okay, so 8 7 is 56, so I can make here 8, which is 1 plus r square by 7. Okay, this will be 8. So now I can equate these two. Okay, now I can equate these two. Okay, so I will equate this, which gives me what? A into r square minus 2r plus 1 is equals to a into 1 plus r square by 7. Okay, okay, this is equal to this. So if I cancel it out, I get 7r square minus 14r plus 7 should be equal to 1 plus r square. If I move it, I get 6r square minus 15r plus 6 should be equal to 0. We get r square minus 5r plus 2 should be equal to 0. Okay, dividing it by 3, we have r is equals to 2 and r is equals to 1 by 2. Now you have got, okay, find the numbers. They're telling to find the numbers. We got r is equals to 2 and r is equals to 1 by 2. Okay, now we want to find a. Okay, we want to find a. How can we find a? Sum of the three numbers is, okay, sum of the three numbers is, so sum of the three numbers is what? Now let's find the a, then only we will able to find the number. Okay, so from where we should find it easily. Okay, let's put here only. A is nothing but 1 plus r square, 56. Okay, right? And if I substitute 2, 1 plus 2 plus 4 should be 56. So we are getting a is equals to 7. Okay, so we are getting a is equals to Okay, 8 is 8. Okay, a is equals to 8. Similarly, now let's check whether by putting r 1 by 2 can we get a different. 1 plus 1 by 2 plus 1 by 4 is equals to 56. So what we are getting, if I make it here 4, it will be 4 plus 2 plus 1 by 56, and here will be 6 plus 1 7 by 4 is equals to 56, 13. Okay, so 56 into 4 upon 13. Okay, okay, 15. Okay, let's check what. Okay, so let's calculate. Okay, this should be 7 only. Okay, that's why our calculation was, we were not able to calculate fast. Okay, so it is nothing but 32. So we got our a. So when r is equals to 2, a is equals to 8. When r is equals to 1 by 2, a is equals to 32. So now you can find the three terms because you got the a and you got the r. Okay, now that you can find yourself. Okay, it will just consume, okay, and make the lecture large. Okay, so just let's try to avoid that thing. Okay, now let's move on to the next question. Okay, so you will get a lot of situation, okay, from these lectures. Okay, okay, from how to deal various situations. Okay, that is our main target. Okay, the product of three numbers in GP is 125 and the sum of the product taken in pair is 175 by 2. Then okay, find them. Okay, now they have given an idea of product. Okay, so we will take a by r, a and ar. Okay, now here you can see a cube will be automatically 125, which gives me a is equals to 5. So we got our a, sum of the product taken in pair. Okay, so a by r into a into ar, and a by r into ar is nothing but 175 by 2. So what we get, a square is nothing but 1 upon r plus 1. 175 by 2, it is 25, and this is 25. 25 5 is 100, 6 7 it's okay, this can be okay, let's think. So 25 and this is 25. Okay, so let's put 25 into 1 by r plus 1. Okay, instead of doing calculation on the spot, let's do it in step. So this will be 7. So what we get, 1 by r plus 1 is equals to what? This is 7 by 2. Okay, so we got this thing. Now if we further do, r square plus r plus 1, okay, is equals to nothing but 7r into 2. Okay, this is 2r square plus 2r plus 2 minus 7r should be equal to 0. 2r square minus 5r plus 2 should be equal to 0, which gives me what I can, okay, r is equals to 2 and r is equals to 1 by 2. So again we got r is equals to 2 and r is equals to 1 by 2. Now you can, there is only one a is equals to 5. Now for each r there will be two set of number possible. Okay, so you can check them, okay, and get your answer. Okay, then now there is no need of doing it further. Okay, you can calculate that much. Okay, so let's move on to the next question. Okay, the next question is this, which is telling find the product of three geometric means. Okay, find the product of three geometric between 4 and 1 by 4. Okay, product of three geometric means. Okay, if I get my r, I can get the product of three geometric means. Okay, which is 1 by 4, b by a, which is 4 upon, we want to find three geometric means, 1 upon 3 plus 1. Okay, it is nothing but r is equals to 1 by 16. 16 is nothing but 2 to the power 4. Okay, by 1 by 4. Okay, so we are getting 2 power minus 4 power 1 by 4, nothing but 1 by 2. Okay, so we got r is equals to 1 by 2. Okay, now we want to find g1 g2. So g1 into g2 into g3, okay, will be what? It will be nothing but a cube into 1 by 2 into 1 by 2 square. Okay, 1 by 2 square into 1 by 2 cube. Okay, which gives me what? 4 into 4, 64 into 1 by 2 into 1 by 4 into 1 by 8, which is 1 by 64 into 64. Okay, so we get 1. Okay, so the product of the three geometric means is nothing but 1. Okay, how we got that? We found the r. We, as I told, g1 can be equal to 1 a into r, g2 will be a into r square, g3 will be a into r cube. So our main motive was finding r. So as I have told you, that easy method in GM, okay, that is finding r and then getting them, is easy, and same goes in AP. That rather than using the direct formula a power n plus 1 minus k b power k the whole upon, like that. Okay, 1 upon n plus 1, don't go for that. Okay, if the calculation is easy, then you can go, not a problem. Okay, now let's move on to the next question. Okay, this is the 14th question. Okay, the question says, find the two numbers whose arithmetic mean is 34 and the geometric mean is 16. Okay, let the two numbers be a and b. So a plus b is nothing but a plus b by 2 is nothing but 34. So a plus b is what? 68. Similarly, geometric mean GM of that is nothing but under root AB is what? 16. So it is what? 256. Okay, if I move the under root here, it will be 256. Now what we can do? Find the two number. Okay, so what we can do? Okay, now if I consider it x square minus, okay, 2ax plus, okay, g square is equals to 0, this, okay, this as my our a was 32, this will be 68. So x square minus 68x plus what? 256. G square is nothing but 256, should be equal to 0. Okay, now let's find the root. Okay, a and b, and the root will be nothing but a and b, as we have discussed earlier. Okay, so how we can, let's find its root. Its roots are what? Okay, its roots are 64. X minus 64 plus 4. Okay, x plus 256, which gives us x is equals to 64 and x is equals to 4. Okay, so we got the values of a and b. A is equals to 64 and b is equals to what? 4. Okay, now the other approach can be getting a minus b the whole square. If you know this thing, it is nothing but a plus b the whole square minus 4ab. If you substitute the value a plus b, it's what? 68 the whole square minus 4 into a into b, which is nothing but 256 into 256. Okay, then what you have? You have 4 624 minus 4 into 2 1024. Okay, so what value you have? 3600. Okay, and this is what? Equal to a minus b the whole square. If I move the square that side, I get it as 60. So a minus b as 60 and a plus b at 68. So you can easily get 2a is equals to what? 128. Okay, 128, and then a is what? 64, and similarly b you will get 4. So this was another method of getting the answer. Okay, but what I find, using this equation is more easier than using this calculation. It is not means it will not click you at that moment, but this will easily click you because you have done so much quadratic equation. Okay, now let's move on to the next question. The next question is this question. Okay, which says, if the arithmetic mean of two positive numbers a and b is twice the geometric mean, then find the ratio. Okay, that is a by b. Okay, if the geometric mean of two positive numbers a and b is twice the geometric mean, so two positive number a plus b by 2, okay, is twice 2 into under root ab. Okay, is twice geometric mean, which is nothing but a plus b is nothing but 4 under root ab. Okay, but instead of, okay, so I got a plus b as 4ab. Okay, so let me put it as 1. Okay, a. Now if I know this thing, what I can do it in one more way. If I square both the side, a plus b the whole square is nothing but 16 into ab, and this is what? A square plus 2ab plus b square should be equal to what? 16ab. If I move 4 here, what I get? A square minus 2ab plus b square is equals to what? 12ab. This is nothing but a minus b the whole square. This is nothing but 12ab. So we are getting a minus b as nothing but under root 12ab. Okay, now if I divide a plus b upon a minus b. This is nothing but 4 under root ab upon 12 under root ab, under root 12 ab. Okay, under root 12 ab. What we have? A plus b upon a minus b. Okay, a plus b upon a. If I apply component and dividend, a minus b upon minus a plus b minus a minus b. Okay, this is nothing but under root e. This will go out, and what we will left with 2 upon under root 3. Okay, and here will be nothing but 2a upon 2b, which will give me a by b is nothing but 2 by. Okay, this will also be okay. This is plus. Okay, after this we will apply component dividend to here, which will give me 2 plus under root 3 upon 2 minus under root 3. Okay, so I have 2 plus under root 3 upon 2 minus under root 3 as my answer. Okay, which is what we needed to find, that is the ratio of a is to b. Now the second way of doing it, okay, is that a, if I call am as a and gm as g, a is nothing but twice g. So in the quadratic equation x square minus 2ax plus g square is equals to 0, I can replace a as 4g, x plus g square is equals to 0. Now if I found x, what is 4g plus minus under root 16g square minus 4g square upon 2. This is nothing but 2g plus minus under root 4g square minus g square. Okay, 2 will cancel out, 2g plus minus under root 3g square if I take g common. Okay, and a and g are its root. Okay, so 2 plus minus under root 3 if I take g here common. Okay, so a by g is nothing but 2. Okay, 2 plus root 3. Okay, similarly 2 by root 3 plus 2 minus root 3. Okay, so from here we get this thing. Okay, you can divide it. Okay, the ratio can also be equal to a minus root 3. Okay, so we are done with this problem. Okay, this approach, how you will click, because you have done this quadratic thing. Okay, so you can see how it is applicable. Okay, how it is working for us. Okay, deriving a formula and then doing the question on it, it will improve your understanding of quadratic equation plus the sequence series application. Okay, so now you have, means if you have done quadratic very well, then you will feel very comfortable in this thing. Okay, now let's move on to the next question. Okay, the next question is this 16th question. Okay, which says let a1 a2 a3 and b1 b2 b3 be the two geometric progressions with a1, okay, a2 a3, okay, till what, a1 is equals to 2 root 3 and b1 is equal to 52 by 9 root 3. If 3 times a99 b99 is equals to 104, okay, then find the value of this. Okay, so what we can do, so 3 times a99 will be what? Okay, there is nothing else we can do here instead of opening it. Okay, so it was a1 into r power, okay, r power 98, okay, r1 power 98, and similarly here b1 into r2 power 98, okay, should be equal to 104. So it should be equal to 104 by 3. So here a1 into b1, 2 into root 3 into 52 into root 3 by 9 is equal to r1 98 upon r2 power 98. Okay, so here 3 will become 3, this will become 9. Okay, so 3 by 2 into means 104 by 3. Okay, so r1 power 98 upon r2 power 98, okay, should be 104 by 3. So this is cancelling with r1 into r2, means r1 into r2 is nothing but 1. Okay, so here if you see, now we are getting idea that a1 b1 b2, we want to find this sum, and a2 by b2 upon a1 by b1 is nothing but r1 into r2. Okay, and it is telling it is 1. If it is 1, then my first term a1 into b1 will also be 104 by 3. My second term a2 b2 will also be 104 by 3. Okay, so it is still n terms. Okay, so I can take 104 by 3 common, and here will be 1 plus 1 plus 1 plus 1 plus 1 plus till n. So it will be nothing but 104 by 3 into n. Okay, now this question has some error. Okay, they have given the wrong answer. Okay, the question is wrong. Okay, if it was like this, finding I is equals to 1 to 1 0, okay, 1 0 101. Okay, then what, AI into BI, then it would have been, how many terms it would have? Okay, I is equals to 0 to 1. Okay, it would have 102 term. Then it will, if we would have taken 102 times, it will be added, and we would take it 104 by 3 common. Okay, and after this we would have got answer. Let me calculate. Okay, let me calculate. We would have got 34 into 104. Okay, and this will be equal to 3536. Okay, so the question has some error. Okay, if the question was from I is equals to 1, you have to find this thing, then the answer would be like this. Okay, so the book has some error. Okay, although I have cleared it. Okay, but what the actual answer should be, I have told that it should be 104 n by 3, and if the question was like this, the answer will be 3536. Okay, so we are done with GP, decent number of question, and we will do some more question on GP, and then we will move on HP. Okay, till then take care. Okay, we have done insertion of GM, geometric mean, okay, quadratic equation and sequence series, some little combination of root questions. Okay, so till then take care. Okay, see you in the next video.